Hey folks, this is tutorial 17 in a playlist that I've prepared for doing certain basic problem in the 3D Experiences FEA module. Now keep in mind that the uh, native FEA solver in the 3D Experience is the Abacus program, but we are not really relying on that. So, if you look at the videos that are prepared for the finite element analysis using 3D experience, most of them or many of them are using a single part. I've also done several which involve assemblies, but there are some subtle issues, and these are not advanced issues. It's just that the how to do process, if you're dealing with an assembly into the experience and you have a structure which is relatively simple and you don't want to basically kill a fly with a cannon. Okay, this is why I call these tutorials as not being rocket science. So the problem that we have is actually this structure which is made of which is made of steel, and the left end is clamped. This left end is clamped, and this right end, the top face of it, is subjected to a downward force. And we're going to do this thing as a simple linear analysis. And you might wonder, why should we do that as an assembly? In fact, we don't. If you create a part which looks like that, you can solve the problem exactly uh, as I've done things in the past with parts. However, on purpose, what I would like to do, I would like to view this assembly as a collection of four pieces, and on purpose, I'm going to make a single piece here, and then basically make an instance of that and make a sub-assembly like that, and then copy that and make another sub-assembly. So this is why this is some subtle issues. Okay, so obviously this is not the way most people are going to solve it. But what I want to do is I want to create this assembly made of two sub-assemblies like this, and the sub-assembly, each one of them is made of these two pieces, identical pieces. So what I'd like to do is only mesh one of them, the original one, and then see how that's going to be inherited by the rest of the structure. Okay. Now in this presentation, I have prepared slides which walk you through the steps. However, uh, at the very end, once this is all done in 3D Experience, I'll come back and go through these slides one by one without any audio, so that if you're interested to catch the slides in one place, you're going to have the opportunity to do it at the very end. Okay. Okay. One of the things that I'm going to do is use the linear multi-instantiation in order to basically duplicate a part, and you'll see that it's going to come up. So the first thing is, because linear multi-instantiation requires a direction, so does, of course, a pattern, rectangular pattern. What I'm going to create is a dummy part, a dummy 3D shape, and its sole purpose is to hold the coordinate system here, coordinate axis, so that the different directions of this axis can be used in order to pattern the thing. And once I create this, then I'm going to create my original part, which is just a block 40 by 40 by 200 millimeters, and Young's modulus, properties of Young's modulus. Okay, so let's go ahead and do that. I'm already in the assembly design. Let me rename this thing so that I can find things later on. So I'll call it tutorial 17. In case you have to look for it later on, tutorial 17. And by the way, this is 2024. So this is release 2024x of the 3D experience. Okay, I'm going to save this thing. All right, so we put the cursor on the top, right click, insert, a 3D shape. And I'm going to say, it doesn't matter which one of these you pick, but I'll pick the top one, 3D shape. And notice that it did create a 3D shape for me. And I want to get into that part and create an access system. So if you look under essentials, here's the access system. What it does, it creates an access system there. And I'm going to use that in future. It's right here. Okay, the next step is go all the way to top level assembly, all the way to top level assembly, okay, and then insert basically 3D part. So let's go ahead and do that. So right click, insert 3D part right there, okay, over here. And this is going to be the one that actually make the original 40 by 40 by 200 millimeter block, okay? So let me go to the part design. This is assembly design. Double click on the 3D shape. So you go into part design. On a convenient plane, on that vertical plane, I will sketch. I'll sketch a, a, a rectangle that is, well, I'll make it like that. Okay, dimension it 40 by 40. So this is going to be 40 millimeter and 40 millimeter this way. Okay, exit and then padded by 200 millimeters. Okay, so what you see here is actually this block. Okay, let me apply material properties to it. So let me go ahead and tools. I'll make one. So create a material, and I'm going to call this thing tutorial 17. I already have materials like that, but since I want to show you the whole process once again, I'll call it steel. Steel. I'll go through the initial step. Okay, something is wrong here. Tutorial 17, steel. Okay, and then we say okay. Make sure that the simulation is checked here, which is already. All right, so it's going to be created right there. You see that? Tutorial 17 steel. And I'm going to say apply, minimize this window so that I can apply it to this part. It doesn't matter where you apply it, the top or the bottom, doesn't matter. Here I'll apply to the part, makes no difference. And the check mark, green check mark. And notice that it is created, so I'm going to go double click on it and put my values in. So it is a structural problem, and all we need is material, Young's homogeneous Poisson ratio. This we don't need the density, but if you want, you can put it in there. So, but anyway, right here, mechanical, elasticity, elastic, and this is 210 gigapascal on Poisson ratio 0.3. All right, good. It's already done. So let me save this thing. All right. So where are we now? We are at this stage. Okay. Now, what I'm going to do is I'm going to, uh, in this part, in this 3D part, I'm going to measure. Okay. So it's insert the finite element model. So what I can do is I go while I'm here, right there. See that? Right there. Right click, insert, insert finite element model. You click on it. So what's going to happen is you're going to mesh this part. Okay, so we are right here. Okay. So what I did, I said insert finite element mesh. Okay, that's what I've done here, step 3. And now we're going to go to the rest. So let's go to the rest here. Double click on that line so that it throws you into the basically the mesher. So double click on that. Notice that this whole thing changed, and you click on the mesh. right there. And we're going to do a sweep mesh. And I want it to be swept in this direction, so I select this part, except that notice that the way it's going to sweep it is from left to right. I don't want to do that, so I'm going to say manual sweep. I'm going to remove these. So for the first face, I'm going to, of source, I'm going to select this, and for the target, I'm going to select the other one. If it's already like that, you don't have to go through that step. So now I'm going to sweep mesh in this direction, and I'm going to have 220 millimeter size and 7 layers. And I say mesh here, mesh, and notice that it meshes it. And then we say, okay. So what we have done is basically this step, swept mesh. Now we have to do the properties, 3D section properties. So go back here, click on the properties tab right there, click properties tab, and there is the section, solid section, and you select the part body here. Notice that the proper material is picked. We already put that thing in there. And what we have done now is basically this step. Okay. So now what we're going to do is we're going to go and try to create an instance of this, because I want to show you what linear multi-instantiation does. So what we're going to do is we go all the way to the top. You see, all the way to the top. You go all the way to the top level assembly. And then you select this 3D part. You see that? This is the 3D shape. I don't want it. This is the one that, this is not the one that I want, okay? But I went all the way to the top and then click on this. And notice that here, it allows you to do linear multi-instantiation. You click on it, and what happens is that whatever you used before is going to be used here. I used 2 layers before. If you want more, you can make it more. If you want other direction, you can select the other direction, but I don't want to do that. So I'm going to go back to 2. Notice that if I select this direction, let me cancel that for a second. Let me try again. So we went all the way to the top, click on that, linear multi-instantiation, okay? So if you want another direction, go to your 3D access system that you created, okay? And first of all, this is fine. And let me see if the access system is showing up. Make sure it shows up. You can stack it in this direction. I don't want to, but I want to show you what happened, why I created that. Because once I display that, you can see that it shows in the screen like that. But I don't want that. I want this direction as I had before, and I want 2 layers, just like that. That was the purpose of this. One purpose of that was this. I could have done something else, but anyway, when you're done here, you click anywhere, left click anywhere, and it shows you the part, okay? So the instance of it. Now, I also make a comment here. Now, notice that sometimes when you go to top level assembly, you click on that, you don't get this icon. I'm not sure why, but anyway, I'm just reminding you that this could happen, but anyway, it's fine, as you can see. So what we have done is basically this piece. We have done this, okay? All right. Now, notice, by the way, if you go back here, you see that what it did, this was the original part that I made, and I meshed it. And what I did by linear multi-instantiation, it created another 3D part here. And notice that it also has its own mesh, and it's exactly the same mesh that the original instance had. Okay, you can see what happened. We meshed this thing once, and because these parts are all identical, so we just use copies of it, basically, a linear multi-instantiation, and then it's going to do the mesh for us also. Okay, good. So what's the next step? Then what we want to do is I want to take these two parts and put it in an assembly. Okay, so we go here, back here, and we go all the way to the top. We say right click, insert. I want a product right there. So this is going to be where these two, I'm going to take it and put it in there. Please note that I'm making this problem complicated on purpose because I want to show you how this can be done using these subtle issues. So first, I'm going to take this fellow and I'm going to put it in there. And I'm going to take this fellow, left click this fellow and put it in there. So notice that this sub-assembly has these two parts in it, 3D parts in it, and they have their own mesh as we just discussed. Okay, very good. Now, what I want to do is I want to copy this and paste it in there so that I have two of them. But before I do that, let me make sure that these are in the right spot. In other words, these before I make a copy of that, make sure that I have these in the right position. So let me go back to this assembly right there, not the original assembly, the one that I made right there. Okay. So we are in assembly design, and then there is this, for example, if you, I don't want to create constraints, but instead what I want to do is I want to use the snap option and, things that do not create constraints. So for example, notice what this thing does. It says move selected object. You select a component, you click on that, and then it says which one. So I'm going to select the second one. And notice that I can take this thing and rotate it 90 degrees. So if I double click on this opens up, and I want to rotate this thing about the Z axis by, or about what axis? About the Z axis by 90 degrees. And I say, see, 90 degrees, Z axis, I already put the number in there. And I say, do it, it'll do it like that. There are no constraints that are created. And then you say green check mark, so it's like that. Now we're going to do snap this point to that point. Okay, good. So I don't have any constraints here. All I did, using the snap feature and manipulate, just reoriented these so that it's in the right spot. So you go all the way to the top. I'm not actually sure. Is this the way I wanted it? Just one second. Yeah, that's exactly. Oh, let me see for a second. Yeah, that's exactly what I wanted. Very good. Excellent. So let's go back. And then we go all the way to the top, all the way to the top. Copy this, right click copy. Where's the copy? Right click. Oh, I'm sorry. We went all the way to the top. Select this, right click copy. Copy. And then we go here and paste it. So what happens is a second sub-assembly is created. You can see that right there. You can see that. And it has the same shape. It has the same mesh as the original that what I did. This is the second sub-assembly that I created, product that I created. Okay, very good. Okay, it's just a matter of putting in the right spot. All right, and how am I going to do that? This drawing seems that, let me see for a second, what do we want this thing to be? Yeah, so I want to turn this thing around and then put it there. Very good. So let's see for a second. Let me first of all move these things. So let me move these things so I can see it better. Let me use the. Remember, you have to be in assembly design in order to be able to move these things. So I'm going to say move it. Move this sub assembly. I'm going to move it up so that I can see what's going on. Very good. So I want to turn this thing around. Trying to see. I want to turn this thing around. So let's use this again. Yep. So select that. Okay, move it by 90 degrees, rotate it by 90 degrees. About the Z axis, let's see if this thing is what I want. I don't know, one more. Okay, very good. That's it. And then we say okay. And then when we're done, we click on the green check mark. And then we're going to do the coincidence between this point and that point. I think that's what it is. Yes. Okay. So we go here to not coincidence, snap this point to that point. There. Okay. Notice that there are no constraints that are created here. It's just using the snap and this manipulation that we did this. So let's all actually save this thing. Good. So where are we at? We are at this stage. We did this, and then we're going to go and we go to the structural model creation. So let's do that. This is step 13. We already have done this. Okay. So we go here. So we go to 3D corner on the top left, structural model creation. Now this thing pops up and it says you should update it. No problem. Let's go update it. Yes. And then when this thing shows, you go and select the empty FEA model. Empty FEA model. Just wait. And then you say include all these parts. Actually, this one may not be necessary. I don't think it is, but I'll do it anyways because I've done it here. Okay. And then, okay, so let's go. And to minimize this, because this is not going to close, there is no okay or close. So we go up here and just minimize this by this tab, by this minus, minimize it. Okay. So what's the next thing we have to do? We select the setup tab from down here. See the setup tab? And we need to select contributing finite element model. Okay. Contributing the finite element model, which is on the next page. Okay. Contributing the finite element model. Let's go here. You click on that. Now this thing pops up and shows you that there are two sub-assembly, two products here. Each one of them has a 3D part and each one of them has a mesh, which happens to be all copies of this mesh. There could have been other meshes here that you could have selected, but we don't want that. So if you go down here, what you do is you put the cursor on the very first 3D part that you put in there, right there, and then right click and say select FEM on all instances. So whatever was used in the first one is going to be used in this model, finite element model for the assembly for everything else. So that's what I mean. Go here, put the cursor right there. You see that? Right click, select FEM on all instances. So there we are. So this is what you have there. Okay. Right there. Now, to confirm that actually it did it, I'm sure it did it. Of course, you minimize that. You can do that. First of all, let me save. Let me save this. Now, to confirm that it actually did it, notice that it did create a finite element model at the very top. That's for the whole assembly. Okay. If you double click on node and element, it shows you that everything was done correctly as you expected. And you can change element types if you want here, but I'm going to leave it the way it is. I'm not going to do that. Very good. So that I just showed you that this was correct. Okay. Now we go here and we tie the nodes. So what do I mean here? So you go to the connections tab, make sure that you select the tie connection, tie detection, and make sure that you say fine ties. That's within this tolerance. Obviously, that's okay for us. We're going to use the default tolerance. Any two nodes that are within that much of each other basically are going to be tied together. Now, basically using some kind of algorithm. So let me show you what happened here. So that's what I mean. Okay, that's what we just did. We go here. and then click on the find ties, it finds out which nodes are going to be tied together, which areas. And then we say okay. Apply or okay, it makes no difference, but I'll say okay because if you say apply, this is all going to go away, but it really doesn't matter. So okay, that's fine. Let's save everything. All right, so let's go back here. So we just did this. We just did this. Now we're going to go to structural scenario creation, where we're going to do our static analysis. So we go to 3D, the compass on the left corner, structural scenario creation. We use the pull down menu, select the finite element model that was created for the assembly. Remember, in that assembly, we take all these elements which came from that original part and put them in the finite element model, and that's what was called this. Okay, say okay. All right. So basically, what I just showed you is this. Now we're going to do a static step because this is a matter of process. It's not a complicated, not rocket science, linear static analysis. So we go to the procedure, we do static analysis. I don't want to do anything involving nonlinearity. So I uncheck this geometric nonlinearity. You say, okay, all right. And where are we now? We just did this. And now we're going to clamp that end and apply a load there. Okay, so let's go ahead and do that. Under boundary conditions, under clamp, you select that face. This face is going to get clamped. You say okay. And under loads, force on that top face, on this top face, negative 2000 Newton. We say okay. Let's save everything. On purpose, I made the mesh so coarse because I wanted to show you this business of tying things together. It works. So if you go back here, we just did it and simulate and run or run. So we click on the simulate. First of all, any model scenario checks, model and scenarios. Simulation check. There are some warnings here, but that's okay. It's going to run. Yeah, it's okay. It's going to run. Okay, good. And by the way, before I run it, I want to show you something here. You can change the type of the element if you want by double clicking on that. I don't want to do that. Right now it's parabolic. That's okay, but I'm not going to change that. But anyway, simulate right there. Say okay. Very simple problem. And then this is almost done, extracting results. And then close that. And if you look at the second step, this is what you're going to get. And yeah, so that's this. And then there is displacement. You can see that. And if you close this, incidentally, and right click visualization, visibility manager, you can say show me if you want uh, the uh, the loads too. Right there, the load on the clamp. And there's one last thing I want to show you. If you click on this color code set and you change that to tied regions and then say apply, it shows you how the tying is done. So this gives you a guideline on how it's done. So let me go ahead here and start with the first slide on each one of them. I'll give you a few seconds to record it if you want separately, and screen capture, print it if you want.